So now we're going to talk about evaluating logarithms. In evaluating logarithms, we're going to do something that we have actually already done. And we are going to take what we see in log form and rewrite it into exponential form. So anytime that you're solving a log, then what you're basically given is log form. So we have the base of the log, given that is 2. We're given the input of the log is 16. What we don't have is what is on the other side of the equal sign, and that is the exponent. So in this case, we know that the base is 2. We know that the input of the log is 16. And the only piece that we don't have is the exponent. That's our big question. So in order to answer this question, we are going to rewrite what we see in exponential form. So anytime that you're solving a log, you will eventually rewrite that log form into exponential form. Anytime that you're solving a log, you will eventually rewrite from log form to exponential form to answer the question. So let's take the base, write it big. So it's 2 raised to the power, well, we do not know the exponent, I'm going to put that as a question mark, is equal to the input of the log, which is 16. So remember, let's remind ourselves again, this is the base of the log raised to the exponent is equal to the input of the log. That's exponential form. In this case, we have 2 to what power is equal to 16? We do not know what that exponent is. But now, we should be able to answer that question. 2 times itself, how many times will give me to 16? Now, you're welcome to experiment with that in your calculator, but let's just kind of play around over here. 2 to the power of 1 is 2. If the exponent was 2, I'd get 4, so we're not there yet. Let's say the exponent was 3, we'd get 8. If the exponent were 4, we would get 16. So the answer to this, the exponent, that would be 4. Okay, so whatever the exponent is here, that's going to be the answer for the log. So our final answer for log base 2 of 16, the final answer would be 4. This is called evaluating a logarithm. You're given the base of the log, the input of the log, and what you're looking for is what would be the exponent on the other side of the equal sign. Alright, so anytime that you're solving a log, you will eventually rewrite into exponential form and answer that question. And once you answer the question, that's the answer for the log. Alright, so let's do several examples. Let's say that we have log of 100. What we want to know is what is this equal to? So we're essentially looking for the exponent in that log form. In order to answer this question, we will convert to exponential form. What's the base of that log? Now remember, the base is the little number to the bottom right of the word log. If you do not see that word, then it's an implied 10. So the base of this log is 10. Raised to what exponent? Well, that's the part we don't know. Remember, that's our big question. Is equal to the input of the log, which is 100. Okay, so we can experiment with this. 10 to the power of 1 is 10. Too small. 10 to the power of 2, that's 10 times 10, that's 100. That's what we need. So what is our final answer? Well, our final answer is going to be whatever exponent we put on the 10. So what did we put in place of that question mark was a 2. 10 to the power of 2 is 100. 10 squared is 100. My final answer is the exponent that I put on that base. So the final answer here is 2. All right. Log base 3 of 81. Okay, we're looking for an answer to this question. It means I'm going to have equals. We're looking for the exponent. So we're going to rewrite this in exponential form and then answer the question. So it's the base of the log, which is 3, raised to what exponent? That's what we don't know yet. Remember, that's our question. Is equal to the input of the log, which is 81. So 3 to what power will give me 81? So let's try some things. 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. You're welcome to use your calculator for these things. 3 to the power of 4, that's 81, and that's what we want. So what is the answer to our question? Well, the answer to our question is whatever I would put in place of that question mark in the exponential form. So in place of the question mark, I would put a 4. 3 to the power of 4 is 81. So my final answer here is 4. So whatever the exponent is, that's the answer for the log. So our goal is to evaluate these log expressions by converting to exponential form. Alright, so let's try it again. Exponential form. What's the base of this log? Well, I don't see a base, so it's an implied 10. 10 to the power of what? I don't know. Remember, the thing I'm looking for, the thing I do not know, is the exponent. That's what I'm trying to solve for. Is equal to the input of the log, which is 10. 10 to what power will give me to 10? Well, let's try some things. 10 to the power of 1, that's 10. That's the answer I need. So the answer is whatever I put as an exponent in place of that question mark. The answer is 1, so the overall answer to the log is 1. Alright, let's do another one. Log base 5 of 1 is equal to what? So we're looking again for equals what exponent. We're going to rewrite in exponential form. Okay. Exponential form says take the base of the log, write it big, raised to what exponent, question mark, that's what we don't know, is equal to the input of the log, which is 1. 5 to what power gives us 1. Now we want to think back to our zero exponent rule. One of our rules was that any base raised to the 0 power is what gives us 1. So this goes back to that zero exponent rule. If I did 5 to the power of 1, I would get 5. That's too big. So we needed something smaller than 1. 5 to the 0 power gives us 1 every single time. So remember, the zero exponent rule says any base raised to an exponent of 0 always gets us out a result of 1. So in this case, what would I put in place of the question mark? I would put a 0, and so that's our final answer to the log. Right, let's keep going. Okay, natural log of 1. Remember how we say that, natural log of 1. Alright, so we're looking for an exponent. Okay, let's rewrite in exponential form. What's the base of that log? Now remember, when I see ln, I don't see a little number to the bottom right, but ln means natural log. Natural log has a base of e. That's the natural base. So e to what power is going to give me to 1? Now this goes back to our zero exponent rule. Our zero exponent rule says any base raised to the 0 power is going to give us to 1. So our final answer is 0. Okay, so we can kind of start to develop a couple of little shortcut rules. One of our shortcut rules might be this. The more of these you do, the more you say, this seems like I'm doing the same thing over and over again, and you are. So let's develop a little shortcut rule. Anytime that I have a log of any base, and the input of that log is 1, the answer will always be exactly 0. Doesn't matter what the base is. Log of any base, if the input of that log is 1, the answer will always be 0. Okay, Okay, so it's one of our shortcut rules. We'll call that the zero exponent rule if you want, but this is something that's really nice to kind of have tucked away as a shortcut. Alright, so that shortcut would apply here, and that shortcut would apply here. Alright, what about log base 7 of 7? Alright, we're going to rewrite in exponential form. The base of the log, which is 7, raised to what exponent? Well, that's what I don't know. Is equal to the input of the log, which is 7. 7 to what power would give me to 7? Well, hopefully by now we would say the answer would be 1. Alright, we'll have another shortcut rule that would apply here and here. You'll notice that for both of these our answer was 1. Why was our answer 1? Well, let's develop another shortcut rule. Something that we'll encounter a lot. If you're doing log of some base, and what's inside is exactly the same as the base, so the base of the log and the base of the input match, they'll cancel each other out, and basically what you'll always end up with is 1. So there's another shortcut rule that will come in handy. The more of these you do, you'll run into that pretty frequently, and you'll start to think about, is there a faster way? Is this always true? And the answer is yes. The base of the log, the base of the input, if they match, your answer will be 1. Okay. Natural log of e. Okay, so this is actually going to follow in line again with our shortcut rule that we just mentioned. You can use the shortcut, or you can kind of do it that long way that we've been talking about. Either way. But we're looking for an exponent again. We're in log form, we'll convert to exponential form. What's the base of this log? Now remember, when you see ln, the base of that log is e. Okay, we don't see a little number to the bottom right, but when you see ln, you assume an implied base of e. Raised to what exponent? I don't know. Is equal to the input of the log, which also happens to be e. The answer is 1. E to the power of 1 is equal to e. So our answer is 1. Now that actually follows along with the shortcut rule that we just came up with. Because the base of the log is e, the input for that log was also e. So the base of the log and the input were matching, and so we got out an answer of 1. You're welcome to use the shortcut rules. Once you learn them, they're really nice to have. You can kind of skip a few steps, but you have to make sure that you know them. Alright. Log. You see the word log there. We have 10 to the power of 3. That's the input for that log. We're looking for the exponent. Okay, so we want to evaluate this log. We can go to our exponential form, the base of that log. Now, once again, we do not see a number, a little tiny number to the bottom right of the word log, so it's an implied 10. 10 raised to what power, but equal to the input of the log, which is 10 to the power of 3. Now, the only way that these two sides of the equal sign could be the same is if this exponent matches this exponent. 10 to what power equals 10 to the power of 3? Well, the only thing that makes sense is to replace that question mark with a 3. 10 to the power of 3 is equal to 10 to the power of 3. So our exponent is 3. Alright, let's do another one. Alright. So we're evaluating a log, so that means we're looking for the exponent. We're in log form, so we're going to answer the question by rewriting in exponential form. The base of the log. Remember, I don't see a number at the bottom right, but when you see ln, the implied base is e. Natural log, natural base. E to what power because remember I'm looking for the exponent on that base, I don't know what that exponent is equal to the input of the log, which is e to the power of x. Well, once again, the only way that this side and this side could be equal to match exactly is if in place of the question mark, I replace that with x, the same exponent that's on the other side. So the answer for the log is x. Alright, we'll keep going. We're asked to evaluate this log, which means we're looking for an exponent. We're in log form, so we're going to solve the problem by rewriting in exponential form. The base of the log is 4, raised to what power? We don't know the exponent yet, is equal to the input of the log, which is 4 to the power of 5. The only way that the right side and left side could be equal or match exactly is if what I put in place of the question mark is a 5. So the answer to the question is 5. Now for these last 3 questions, have you noticed a pattern? There is a pattern to what our answers have been for the last 3 questions. See if you notice there's a shortcut rule that we're going to come up with for those types of problems. Okay, so we're going to do 2 more examples and then we'll talk about the shortcut rule. Right. Log, and the input is 10 to the power of x. We're looking for an exponent. Right. Exponential form. The base of the log. Okay, well, once again, I do not see a base on the word log. Log, without a little number to the bottom right, the implied base is 10. 10 to what exponent is equal to the input of the log, which is 10 to the power of x. Alright. The only way that the left side and the right side could be identical is if in place of the x in place of the question mark we put an x. So 10 to the power of x is equal to 10 to the power of x. Now both sides are equal, and the answer is what I put in place of that question mark. Alright, next one. Ln, we have e to the power of 7x to the power of 2. So here's the input of the log. We're looking for an exponent. Okay, so if I'm solving a log, I'm evaluating a log, I'm going to rewrite the log form into exponential form. Okay, I do not see a little number to the bottom right of the log. Ln, if I don't see a number there at the bottom right, the implied base is e. So e to what power would equal to the input of the log, which is e, to the power of 7x squared. Well, the only way that the right side and the left side could be equal is if they have the same exponents on e. So in place of that question mark, I would put 7x squared. So our answer is 7x squared. Okay, and did you see the kind of the shortcut maybe for all 5 of these last problems that we did? Okay, so let's add to our list. Let's talk about the shortcut. So a third shortcut. Let's say you have a log of a base, and then on the inside you have a base raised to some exponent. If you look back, you'll notice that in all of those examples, the base of the log matched what was on the inside of the log. If the base of the log and the base of the input match, so they're not exactly the same, but maybe the base on the inside would have an exponent, well, the bases would cancel each other out, and what you're left with in each case is what is the exponent on that base that was on the inside of the log. Okay, so how does this shortcut rule play out? Well, look here. We had log base 10 of 10 to the power of 3. The base of the log and the base of the input match. They cancel each other out, and the shortcut would say your answer is whatever was the exponent on that input, and that would be 3. Okay, so the base here is e. The base of the log and the input, base of the input match. They cancel each other out. You're left with whatever exponent was as your final answer. Okay, even in some kind of more complicated ones, the base of the log here is e, cancels out with the e on the inside. So the base of the log and the base of the input match, they cancel each other out, and the exponent that was left on the input, that becomes our final answer. Okay, this one as well. The base of the log was 10, the base of the input was also 10. We're left with the final answer of whatever the exponent was. So a nice little shortcut rule, the base of the log, the base of the input match, they cancel each other out, and the exponent on the input becomes our final answer. Alright. One last one that we're going to look at here, and that is looking for the exponent again. Okay, so we have log base 6 of 1 over 6 is equal to the exponent. In this case, the base of the log and the base of the input don't match. But there is a relationship between the base of the log and the input. They are reciprocals of each other. Okay, so that's an important word. Way back when we first started talking about exponential functions, and at the beginning of logarithmic functions, we talked about the negative exponent rule. So let's remind ourselves of the negative exponent rule. I'm going to put it here. Okay, so we talked about this in a previous video. Remember, the negative exponent rule says if you have some base raised to a negative exponent, it would equal to 1 over the base, or the reciprocal of the base raised to the positive of that exponent. So in this case, these were reciprocals. So in this case, the 6 and the 1 over 6 are reciprocals of each other. So if we're trying to answer this question, we would go back to the exponential form. I'll just put it here in this box. So the exponential form would be the base of the log 6 raised to what power would give us to 1 over 6, the input of the log. So in this case, since the base and the result are reciprocals of each other, then the answer must be a negative exponent. And very specifically, negative 1. So let's try it out. 6 to the negative 1 power. When we have a negative exponent, I would flip the base, which would be 1 over 6, and raise it to the positive 1 power. 1 over 6 to the positive 1 power would give me 1 over 6. So if the base and the input are exactly reciprocals of each other, your answer will always be negative 1. Now if you want to add that to your list of shortcuts, you can do that. You will encounter that idea later on. So let's just go ahead and write that as maybe one of our shortcut rules. So let's say you're doing log of a base, or log of a base, whatever that is, and your input is 1 over that base, or the reciprocal of the base of the log. The answer will be negative 1. So we have kind of 4 shortcut rules if you want to kind of have those written down. Really nice to have on hand. Now, the shortcut rules are not required, but they are nice to know. These are some things that will always be true, regardless of what the base is. Something nice to have. So that last one, I think, is the most challenging maybe of them, is remembering that negative exponent rule. But if you see that the base of the log and the input of the log are reciprocals of each other, your answer will be -1 for the exponent